In a broader sense, here in this video, we are talking about progressive waves. As I told you earlier, progressive wave is someone that will always moves forward, never comes back. I told you there are two kinds of progressive waves. One is a longitudinal wave, the other one is a transverse wave. Well, what do you mean by a longitudinal wave? If the particles of the medium are vibrating this way, they comes close to each other at a given place, that's called compression. When they move little far away, that's called rarefaction. Again they will come close to each other. Again they will move away from each other, close to each other, and that will be keep on happening. This kind of a wave motion is called longitudinal wave motion. If you notice little carefully, the particles of the medium are vibrating along the x-axis. Direction of the wave motion is also along the x-axis. If the direction of the particles and the direction of the wave motion are in the same way, that kind of a wave is called as a longitudinal wave. Then we can talk about transverse wave. Yeah. The particles of the medium vibrates about y-axis, but the wave keeps on moving along x-axis. So it's the direction in which the wave is moving. This is the direction in which the particles are vibrating. That kind of a wave is called transverse wave. The part above the x-axis is called something like crust. Below the horizontal line is called something like trough. Here, one compression and one rarefaction is called one wave. Here, one crust and one trough is called one wave, one complete wave. How many number of the waves are there per second is called something like frequency. So what do you mean by a frequency is number of waves. What do you mean by that wave? If it is a longitudinal wave, compression plus rarefaction. Or if it is a transverse wave, crust plus trough. This combination means immediately after the compression, whatever the rarefaction it is there. Immediately after the crust, what is the next trough that is there? That is called one wave. How many number of the waves like that are there per second is called frequency. Next point is time taken to complete one wave is called time period. So if you notice carefully, frequency is the number of the waves per second. Time period is the time taken to complete one wave. So these two are, if you look at the definition, number of the waves per second, how many number of the waves are there. This is the time taken to complete one wave. So both are reciprocal to each other. So what we can say is time period is reciprocal of frequency. Her frequency is reciprocal of time period. This time period has a unit second, frequency has a unit second inverse, or in the name of a scientist, it is called Hertz. Now, the I want to explain one more term called something like wavelength. The name itself tells you it's a length of a wave. Wavelength means simply length of a wave. What do you mean by a wave? As I told you earlier, one compression and one rarefaction, or one crust and one trough. So what do you mean by a wavelength is simply the length of, that is length of one compression and its immediate rarefaction, or length of one crust and its immediate trough. So this is the wavelength shown with the letter lambda. This is also the same wavelength shown with the letter lambda. So wavelength is simply length of the wave, that is the length of whatever you defined as wave as compression plus immediate rarefaction, or crust plus trough in a transverse wave. But we can define this wavelength in some another way also. Let us define this wavelength in another way. What is the other way is? That is distance between two successive compressions, or two successive rarefactions. Means what? Look at the diagram little carefully. This is one compression. This is one more compression. The distance between these two can be called as wavelength lambda. Or this is one rarefaction. This is one rarefaction. The distance between them is also called as lambda. Anyway, it is same. Either compression and next rarefaction, or compression and then the gap, there is a rarefaction comes, and again there is a compression comes. The distance shall be the same. That kind of a definition. So if you define in another way, distance between two successive crusts, or distance between two successive troughs, or even in a broader sense we can say distance between two successive points in a wave motion that are in same phase. So two successive compressions are in the same phase, two successive rarefactions are in the same phase, that is the position with respect to a mean position. Two crusts are in same phase, two troughs are in same phase. Or in the other way, the length of the wave itself is also called wavelength. Whatever the way that you define, you finally end up to the same kind of an meaning to that. That's wavelength. So let us consider a wave in motion, something like this. It is traveling like this. Wave is having certain velocity. That's called velocity of the wave, right? So we have just now found that in time period t seconds. What is time period? As I told you, time taken to complete one oscillation. In time period t, one oscillation is completed means one wave is completed. You know, to complete this one wave, time taken is t. The length of this wave is called wavelength lambda, because length of the wave itself is wavelength. This is one wave, one crust and one trough. So its length is wavelength. So I can say in time period t, wave travels or covers a distance or a displacement that is equal to lambda. In time period of t seconds, it has covered a displacement lambda. That implies I can say in 1 second, displacement covered is in total t seconds lambda. Then in 1 seconds, lambda by t. So if you look this carefully, displacement in 1 second or rate of change of displacement. This one, what are you talking? Displacement covered in 1 second is called simply velocity. So velocity v is lambda by t. We also know that lambda into 1 by t, but 1 by t, time is 1 by frequency, or frequency equal to 1 by time. It can also shown with the letter n. 1 by t is nothing but equal to n. So that is equal to lambda into n. That implies what we have got is velocity of the wave is equal to n lambda. So this is a very important expression for the velocity wave, and I have explained and derived it for you so that you can understand from where this v equal to n lambda is coming. It's a very simple equation. You have learned it in the school itself, and this is the origin of that. How do you get it? How do you get it? It is very simple. In time period t, wave covers a displacement lambda. So in 1 second, it covers lambda by t. 1 by t is frequency. Displacement in 1 second is called velocity. So v is equal to 1 lambda. N lambda, where n is the frequency. That's how we have to understand the basic terms like wavelength and velocity of the wave. That's it. Thank you for watching.